Okay, I had a few questions come to me on calculus. The list is on the board. This is from the composite functions section. So that would be on page number 274 and 275. So, yeah, number one. I see why I had a problem with number one. Number one is not as hard as you want it to be, but it's confusing. So, because they give you a table and they give you 0, 1, 2, 3, 4, 5, 6. And then they give you f at x is 0, 2, 4, 6, 8, 10, and 12. And then they give you g at x is 7, 6, 5, 4, 3, 2, 1. And then, like in 1a, they ask for g at f at 2. So if I'm doing something like g at f at 2, I actually work from the inside and go outside. So the first thing I do is I say whatever's in this bracket, that's the x value. So the x value is 2. And what is the f value if x is 2? Well, the f value is 4. So this is 4. And then they want g at 4. So now this is my x value. So 4 and g would be 3. So that's how I would do that. I'll do another one for you. They have f of g at 4. So again, that would be like f of g at 4. You could write it either way. So again, what I would do is I would start at the middle. So this is my x value. So I want to know what g is when my x value is 4. So if my x value is 4, my g is 3. So this is 3. So now it really wants f at 3. So again, now this is my x value, and it wants to know f, which is 6. And so that's what I would do with each of those. If you don't get them all, don't worry about it. I'm not going to ask you anything like that on a test or anything, so don't worry too much about that. 3D. 3D says, I don't know, hold on. 3D, f at x is x squared plus 1. And g at x is x minus 3. And in 3D, they want to know f of g at x. So again, basically, they want you to take the f equation, which is something squared plus 1, but in place of the x, they want you to insert this. Now, I doubt they leave it that way at the back of the book. They might, but I doubt it. My instinct would be to expand that out so that this is x squared minus 6x plus 9, and then this plus 1. And so this would be x squared minus 6x plus 10. That's what I would do with it. And then number 6. My board is getting gross. Gonna have to clean that again soon. Number 6 is long, but it says given f at x is x minus 8 and g at x is the square root of x. I'm just going to do two of them. I'll do A and C. It says find f of the inverse of f at x, and the other one says find g of the inverse of g at x. So what you'll need to do is you'll need to find the inverse of f at x. So remember, if this is y is equal to x minus 8, to find the inverse, switch your x and your y. X is equal to y plus 8. Move this over here. Sorry, I did that wrong. Whoops. If I switch my x and my y, let me try that again. I have x is equal to y minus 8, so I'd move this over here, and x plus 8 would be y. So that is what the inverse is. So if I do f of the inverse of f, it means take my f equation, which is something, minus 8. It's a variable, minus 8. What I'm putting in place of that variable is the inverse, and the inverse is x plus 8. So when I do f of the inverse of f, I get x. And again, I did an example where I explained that when you do a composite of an equation and its inverse, your answer should always be x. So again, if I wanted to find the inverse of this, this is y is equal to the square root of x. So x would equal the square root of y. Well, to get y by itself, I have to square this side, which means I have to square that side. So y would equal x squared. That's the inverse. So g of the inverse of g would be, I'd take my g equation, which is the square root of something, some variable, and the variable I'm going to insert is the inverse, which is x squared. And if I take the square root of something squared, the square root and the squared basically just cancel one another out, and I get x. So that's what I would have. Wicket, why don't you lay down over there? No, go right around that. He obsessively goes left. We're trying to retrain that. So 7C, we're given f at x is root x, and g at x is x plus 4, and in C, they want to know the range of f of g at x. So the range just means what can my y values be, what can my answers be. So to figure out what f of g at x is, I'm going to take my f equation, which is the square root of something, and g at x would be x plus 4. So basically, I have y is equal to the square root of 4. Now they don't ask me the domain, but for me, the domain would be that x has to be greater than or equal to -4, because I need 0 or bigger underneath the radical, because you can't take the square root of a negative sign unless you're dealing with imaginary numbers. The range is going to be that y has to be greater than or equal to 0. Now, I'm going to check the answer at the back of the book, because I could justify a different reason, so I just want to see what they say. So page 274, page 274, 7D, 5, takes forever to check these, 5, 7C, yep, nope, they have the same thing I do, y is greater than or equal to 0. Okay, 16A. Oh, I think I know what 16 is. 16A says, yep, there it is. It says, for each function, and in 16A, the function is 32x squared plus 3. And what they want to know is, what is f and what is g, so that if I do f of g, I would get this as an answer. I think, and again, this takes practice, guys, and I'd love to tell you there's a way to do this. I don't think there is. I think that f would be 32x plus 3. Because that's basically the inside, and g, or the outside, sorry, and g would be x squared. Now the reason why I say that, if I do f of g with that, okay, means take my f equation, which is 32 times something plus 3, but then insert the g equation into the empty space, and the g equation is x squared. So you see how when you put it together, you get this. They really want you to break it apart. Again, don't worry too much about that. I'm really just trying to get you thinking in the right direction for that, because we're going to head into the chain rule next, okay? So there's just a quick answer to some questions that I had. Thanks.